Hello, this is Math 140, day 13. In the second video about inequalities, I want to explore connections between compound inequalities, intervals, and graphical representations. So let's start with what I would call and problems. So consider 3 less than x and x less or equal to 6. Find all x where this and this is true. What does it mean, find? There's infinitely many x values. So how do we describe them? Describe as an interval. Describe graphically. That would be the typical question. And well, as an interval, we would go from 3 to 6. The endpoint 3 is not included. You put a round parentheses there. 6 is included, so you put a bracket. And then for B, graphically, make a number line. You put the 3, you put the 6. 3 is not included, so we give it a hollow circle. 6 is included, we make it a filled circle. And everything in between. Okay. Excuse me. Oh, that's everything has to be said about and problems. But oftentimes when the inequalities happen like this, we can chain them together. Then you often write this as 3 less than x less or equal 6. So you can literally see how the x is between the 3 and the 6. And that's called a compound inequality. Right. Technically, you could have any one of the 3 representations, a graph, an interval, or a compound inequality, and then ask, give me the 2 others. Example, represent 1, 5, so bracket at the left endpoint and a round parentheses at the right endpoint as compound inequality and graphically. So, if 1 strictly no, less or equal, x strictly less than 5, because 5 is not included, 1 is. And on a number line, mark the 1 and the 5. Don't bother about making nice units and putting in numbers between 0 and 10. Just mark the essentials, the 1 and the 5. And we have, now that is essential, the 1 included, the 5 is not included, and everything in between. Okay, since I've talked about and problems, what about or problems? Or problems. For example, x less or equal to or x greater than 4. Represent graphically. Mark the 2, mark the 4. The 2 is included, so full circle. 4 is excluded, hollow circle. And then what? Less or equal to 2 sits here. Greater than 4 sits there. If there's no definite endpoint, it would mean it goes on forever. So that is the entire number line except for this interval of length 2 between 2 and 4. It's not very nice to write this as intervals. It is not one interval. At best, it's 2 intervals. So if you have to, you could write this as 2 intervals. And the one is negative infinity to 2, endpoint included. And the other one is, leave a space here, parentheses open, 4 to infinity, parentheses closed, endpoints not included. And to signify that we want both of them are possible, it's an or problem, you put this, that's called a union, and it means take both of them together. In case if there's an overlap, the overlap would only be counted once, no duplicates. But it does mean all the numbers which are in at least one of those 2 intervals that we specify here. Union of 2 intervals. Of course, it's nicer if you can do it with just 1 interval, and just in this or problem kind of thing, that is not possible. With and problems, it's always possible. Oh, what else have I got? The last bit, to tie it back to the problems with absolute value, inequalities with absolute value. The absolute value of x minus a is the distance between x and a on the number line. So if you're looking at x minus 2 less or equal to 3, we can say that's all the x's which have a distance from 2 less or equal to 3. That was my very first example, I think. So you can mark the point 2, and then the distance of a point x from the 2 is less than 3. So it's 3 units to the right at most, or 3 units to the left at most. And endpoints included, so That's what we get. So the graphical method is really a nice way to look at these inequalities with absolute value. They are always inequalities that can be rewritten in this form. Some of the tools from the toolbox allow you to rewrite this. So you get to this form, and then it will be a shift to get it back all the way to type 1. But you can also solve it right here and say, okay, it's an interval centered at this number that I see there. And the length of the interval is, well, 2 times what I see on the right, if it's a less or equal sign. If it's greater than, then it would be the outside of this interval, like I had in my problem where it's a union of 2 intervals, like at the top of the screen here. So last bit, I want to make the connection to and or problems. And that has to do with the definition of the absolute value. So if in above example, x is greater or equal to 2, then the absolute value of x minus 2 is just x minus 2. And that's supposed to be less or equal to 3. So those two things would have to happen at the same time. It's an and that's invisible. And it gives you some solutions of that inequality. It gives you the right half of that blue interval. All the numbers that are bigger than 2, but less than 5. So it gives you these numbers. Or x is less than 2, in which case the absolute value of x minus 2 is the opposite. So that's 2 minus x. So we have 2 minus x less or equal to 3. And again, there's an invisible and. Invisible and. But it includes this bit down to here. You've got 2 blocks, each of them consisting of 2 inequalities. So for the second block, you can write it as a compound inequality. And what is that? This is uh, 5 less or equal to x. All right, no, -1, duh. For that last inequality, I want to subtract 3 and add x. So you get -1 less or equal to x. Together with x less than 2, we have a compound inequality, -1 less or equal to x, strictly less than 2, which gives me the left half of the interval that I sketched earlier. And both of them together, remember the OR combines, give me the final answer, the full answer to the problem. Full answer is -1 less or equal x all the way up to, what was it, 5. Just so we make that connection, but when you look at the graphical method, it went way faster and easier. So always go with that if you have the choice. This is only to show you how it's linked together and theoretically possible to deal with inequalities with absolute value without any drawing and any graphics. Some people just hate graphics. Maybe there's some of you who hate it so much that they actually prefer to do these two cases. Whatever works for you. And personally, I like it the graphical way. I think that's much shorter. All right, I'll see you in class.